Hello, and let's talk about testing. Testing, you see, is an important concept in programming, not just Python. Although we start off writing simple script files with few lines of code, when we start getting into the real world, you start getting thousands and millions of lines of code. Hundreds of Python files worked on by many people from different divisions in a company, and most likely all of them starting at different time at the company. All the code changes happening over time at different times as people work on the project as the complexity of the code and the size of the code increases. It becomes harder and harder for someone to fix a bug that may arise. Let's say you come into a project that has been around for years. You may modify something that may modify another part of the app that you didn't even think of. And you start creating all these bugs with new features that you introduce into the app. The longer that the code stays in a project, the more likely it is to be touched by different developers. So you see the problem here, right? For companies, this is a huge problem because you're most likely always growing your product and adding more and more lines of code. That means that they're just going to keep making this giant monster that becomes harder and harder to tame and debug. And it costs companies a lot of money. Luckily for us, we have something called testing. And testing can help us solve this problem. As the name suggests, testing is a method in software development where individual units of source code, such as functions, are tested to see whether they work properly. Although it may not be a big part of a coding interview, a lot of companies usually don't think about testing when interviewing people. It becomes more and more important as you go through your career. For example, in my case, when I first started out as a programmer, I didn't know that much about testing before I got hired. But the importance of testing grew more and more as I progressed through my career. And it's one of those things that has made me a better developer. So if you want to become a senior programmer and if you want to have a long-lasting career, you really need to master this skill. Because remember, every serious company is going to have tests and they'll want you to write tests for your code. So let's explore this idea of testing a little bit more. You see, a test is simply another Python file. Now, in my case over here, I have a main.py and a test.py file on my desktop, right here. Usually you have a test file like this accompanying one of your files. So, for example, if you had 100 files of Python or modules, then each of those modules will have its own test file that you can run tests with. Now, this file that we're going to be writing never actually runs in production. It's a file that we run to make sure that before we release this main.py file to production, that everything is working properly. So this is only for development, but we would never actually, the customers will never see this file. Now, before we actually start writing some tests, I do want to remind you that we did learn a few ways to debug our code, right? We learned about things like pylinting that we installed in our Visual Studio Code to lint our code and check the syntax and small errors as we type our code. We also saw how the online REPL that we used another thing called pyflakes, which is just another linter. And then we also saw that PyCharm, our IDE, also had built-in linting. We also learned that we have something called AutoPEP8. Or PEP8, which is the standard style guide for Python. And this allows us to make sure that our code meets a style that the Python community has agreed on. These are the simple tools that allow our code to be checked for simple styling issues or simple mistakes, such as not declaring a variable. But these only get you so far. And testing is a higher level up. A way to, after you do linting, after you do something like PEP8, after you've met all those requirements and your file runs, testing is a way to actually check even more of your code. So how do we write these tests that I keep talking about and not coding? Well, let's find out. Luckily for us, there's a built-in module from the standard library that we can use. And it's called unit test. So in the next video, we're going to start writing some tests, writing some sample code, and show you exactly how they benefit us as programmers. I'll see you in the next one. Bye-bye. Welcome back. Let's write our first tests. Now, we're going to just have a simple function that we run in this program. We'll create in our main.py file let's make this a little bit bigger. We'll say that we have a function called doStuff. Yes, very descriptive function. Now, in here, we'll just say that we accept a number, and we'll just simply return num plus 5. A very, very simple function. So let's say this was our code that builds our app. So this is just one function, but hypothetically we have many functions that we want to test because these are actions that we're going to perform in our code. So the way unit test works is like this. We have our test file, and after we import our unit test, we want to import, the file that we want to test. In our case, it's main.py. So let's just import main, which is right here. Or we can just import the function as well if we want. But in our case, hypothetically, we have many functions here, so we can just import main and use all the functions available there. Now, the way unit test works is we create a class and then name it whatever we want. In here, we'll have all our tests. So let's just call it test main. And we inherit inside of this class what unit test gives us, which is a test case. So this is just a standard way to work with unit test. So we're inheriting whatever unit test case is, and now we have that functionality available in our test main class. Now in here, we can start testing and writing code to test. So how can we test main doStuff function? Well, we simply say, hey, let's write a function in here or a method because this is part of a class and say, hey, I want to test doStuff. And in here, it will receive self. Now in here, I can test my code. So I can say if number in here is equals to 10, I'm just giving it a random number, then I'm going to say result is going to equal main.doStuff. So remember, doStuff comes from main, which is the function that we want to test. So I want to run the doStuff function, and in here, give the parameter num, which I've just given here. Or let's just call this test param. So this test param, we're going to run the code, and we're going to get a result. And this last line is the key part of unit test. Unit test allows us to say self.assert equal. And assert equal is something that we get when we inherit from unit test. And assert equal says, hey, assert or make sure that these two parameters are equal. In our case, I want to test that the result is equal to, in our case, 10 plus 5 should equal 15. All right. Now, finally, in here, we just run the unit test. And the way we run the unit test, because this is just one test that I did, I could have done multiple tests. All we need to say is unit test dot main, which will run the entire test file within the test main. Now, if I run this now, all I have to do is say Python 3 in my command line and say test.py. and I get, okay, ran one test in, well, super fast, in 0 seconds. That was nice and quick. Now, let's say I do something else where I assert equal that this equals 10. If I run this, look at that. I get a fail. What failed? Well, the test to do function failed. On line 8, so that is right here, we have an assertion error. We got 15, but we expected 10. How cool is that? So I now have one failure, so I need to fix my code. So something's not right here. Now, in my case, this is because I've asserted the answer to be 15. But what if we create another test in here and check, hey, what if we have test do stuff 2, and this time the test param is actually going to be a piece of string. So what do we want the function to do? Well, in our case, maybe it gives us a error, maybe a value error. So I'll just say value error, because this shouldn't work. If I run this now, let's clear this. If I run this now, all right, I have 2 tests, but I have 1 error. And I see here that I'm getting an error saying that, hey, I'm getting a type error. Can only concatenate string, not int. Now, in this case, what actually fails is the test file, because what we've just done actually fails our function. But right away, I see that, all right, well, this is something that we need to fix. So I can go back to main and say, hey, I want to make sure that we catch any errors, like type errors or value errors. So the first thing I can do is just say int number. And if I save that to make sure that we convert something to an integer, and I run this, all right, now I get a value error, invalid literal. So int can't be run on this piece of string. Okay, so another thing we can do to improve our code is to wrap it in a try except block, right? And then we can catch, so let's say except, and in here, accept a value error. And let's say as error. And in here, we can do whatever we want. So we can return, if we want, the error, or we can even raise the error. In our case, let's just return the error. And I'll show you why in a second. Now, if I ran this, you see that my test fails, but now it's actually an assertion error. The assertion error is coming from our test file over here. And I'm asserting that, hey, I want to make sure that the result and the value error are equal. Now, you see over here that there's a bit of a mismatch. We have a value error over here doesn't equal the class value error. Now, this is a bit of a trick where because we're returning an error, it's actually an instance of the value error class. So we need to do something like this. We need to say, hey, is instance, and say, what is it an instance of? Well, is result an instance of value error, like this. But the problem here is that, let's make this a little bit bigger. The problem here is that assert equals is going to expect 2 parameters, 2 things that must be equal. But here, I just want to make sure that this returns true, that the result is an instance of value error. So how can I do that? Well, besides assert equal, we have a few other methods that unit test gives us. If I go to the unit test documentation here, on the first line it says the list of assert methods. So here I see that these are all the methods for asserting and testing our code. The one that we probably want is this one, assert true, to check if something is true. So if I do assert that this is true, and I ran my test. Let's clear this and run my test again. There you go. I ran 2 tests and everything seems to be okay. And again, to go over this, why is this? Well, I'm running my test file, and then I'm going to run the test, do stuff, which is going to be okay. Then I do the second part, where the test parameter is something that we don't really want, which is just a piece of string. The result is going to give us a value error because we've caught this error and we're now returning the error. And then finally, we run this piece of code. Hey, is this true? Is the result going to be a value error? So you see what we're doing here. What we're trying to do with our tests is to improve our function by simply trying to break it. So we want to break our function and see, hey, can I trick this function into giving me an error? And then once you do that and a test fails, then you go back to the function and try to fix it, kind of like we did here, which is really, really cool. This is a common practice with testing, where you try and break things until, well, the function becomes perfect. Now, I want you to take your time here and see if you can break this function and maybe add a couple more tests. In the next video, I'm going to add a few more to make this function even better. I'll see you in the next one. Bye-bye. Welcome back. Let's continue with our unit tests. Now, one thing I noticed here is that when looking at the documentation, we actually have an assert is instance. So we can actually, instead of saying assert true, just use the assert is instance, which we give A and B. Again, all these assert methods, there's no right one. You can use whichever one you want as a tool to improve your code. So in my case, let's just change this to assert is instance and fix this like this. So just a little cleaner. Let's see if this works. All right, everything is still good. Okay, let's try and break our code again. So everything is looking good, but what if we do something different? What if we do, let's say, add another test, and we'll say test do stuff 2. Usually you want to name these functions a lot better so they're more descriptive. But in our case, this is fine just so we can see how they work. This time around, let's do test param is going to equal, how about a none type. So now if I run this, let's run this code again. And by the way, you might notice here how I'm copying code in a test. And you might think, well, can we just make this simpler and not repeat ourselves? And you can totally do that and make things a lot easier. But when it comes to tests, because they don't go into production, and this is just for development purposes, you really want to have tests that are easy to read so that other people understand your tests. Because when it comes to testing, readability is really, really important. We don't care as much about not repeating ourselves and making our code efficient, nice and small. So I like writing tests that are really descriptive, really obvious. All right, in here, let's say self.assert equal, and what should this be? Well, in this case, I'm expecting a value error. So let's do this. I expect that the result will be a value error. I'm going to save and run my test. All right, I get an error. It says this is a type error. Int argument must be a string. And I'm giving it a non-type. All right, so this isn't handling it properly because it just doesn't work with the int. We get a type error. So how can we fix this? How can we adjust it in case we get a non-type in the parameter? Well, first off, let's give it a default parameter. Let's say the default parameter is 0. If I run this again, I still get the error. Okay, so we still haven't fixed it. The argument must be a string, a byte-like object or a number, not non-type. Okay, so we're still not checking for the non-type. So another thing we can do is say if number, so we're checking if we have the number value, because remember, this is going to default to true if it has any sort of numbers or, well, any value. But if it's a non-type, it's going to turn into false. So in here, if number, we can say return this. Else, otherwise, we'll return please enter number. So I'm going to save this and now change this, because now we should expect please enter number into my test. And I'm going to say assert equal that result is going to be please enter number. If I now run my test, let's clear this. Oh, looks like I'm getting ran 2 tests in 0 seconds, but we have 3 tests, and that's because you see here that I named mine the same. Remember, if you name the thing the same, well, it's only going to run one of them. So make sure that all the test names are unique. So I'm going to run this. All right, ran 3 tests and everything is working fine. Very, very cool. So you can see here how we went from a very simple function and we started catching these errors and started realizing how our function was too simplistic, that if we received a wrong input, like a string or a non-type, well, as soon as we did that, our function failed. So by using tests and as testing and breaking things, I was able to improve this function so it's more durable, so that now it works a lot better in production, right? And this is the power of tests. It allows us to check for any mistakes that we may have made, because maybe we wouldn't have thought of doing something like this initially. But by writing tests alongside our code, we were able to improve the function. Now, one last thing I want to add. Let's just add another one over the tests and say that this do stuff for, what if the test parameter is just an empty string? We should get please enter a number. So if I ran this, all right, 4 tests are passing. So it looks like our code is working nicely. Now, to finish off here, I want to just point out a few things. I'm calling here unittest.main, but this has nothing to do with the actual file that we wrote, which is the main file. If, let's say, I rename this, so let's go to my desktop and say I want to change this to script.py. Let's now open this, in my case with Sublime Text. Let's go back here. So you see here that main.py is, well, doesn't exist anymore. It's asking me to save. So this is a completely different file now. If I do script here and simply change all the instances to script, if I save this and now run, this still works. Unittest.main simply says, hey, just run all the tests over here. Now, one thing, and this is a common practice that we've talked about before, is because you want to say, run this file if this is the main file being run, because we don't really want to import test main or anything like this into other files. These are individual files that should only be run when we run our tests. So I can just say if __ name equals __ main, then run this piece of code. So now if I save this and run, there you go. Everything is still working, but now I make sure that this is a test file and I'm only going to run this code if it's the file that's being run, if it's the main file being run. So this is a standard way that you would have your unit test done with the unit test module. Let's take a break and talk a little bit more about tests in the next video. Welcome back. Let's talk about a few more neat things that you can do with unit test. And remember, you can always go to the documentation on the Python website and learn more about some of the things that you can do. But notice here how at the end we added the if name main. Some of you may be wondering why this is useful, because so far we've just ran it from the command line as a single file, and that has been working. But usually you have more than one file and you have each module tested with different functions, right? So ideally you want to run all these tests in unison. And the way you do this is to write Python and then -m and then give it the unit test that you want to run. So now if I do this, you see that everything is working. Let's say I add a new file here. Let's say touch test2.py, which is a short command on Macs to just create a new file. So now on my desktop, let's just copy this test that we originally have, go to my desktop and open up this in Sublime Text. So now if I copy and paste this, the exact same thing, and I save this, go back to my code and run unit test, you see that I have 8 tests now that are being run. And because I've added this if name main, I'm able to run all these tests with just one simple command. Now another neat thing is that we can do something called -v, which stands for verbose. And that is, when we do this, we actually get more information about the test that we ran. So it gives you a little bit more detail. You see which tests we've run and which ones are okay, which ones have failed. As a matter of fact, I can even add comments and doc strings to my tests. So let's say test do stuff. I can say single quote 3 times and simply say hi. If I run this again with the -v command, and this has to be on a single line, I believe. Let's save that again and run this. Look at that. I also get some comments. So maybe I wanted to add a few comments on my tests. I can add those as well. What other neat thing can I do? Another default method that we get with unit tests is something called setup. And setup allows us to run a piece of code that sets up before each call of the test. So for example, whatever I write in here, let's say I wanted to set up my test and just print about to test a function. Now, because I have this, if I run my code now, you see that before each method, I run the setup method first. So you see that I say, about to run a function, about to run a function, about to run a function, and about to run a function. And then we have our test2 file that we haven't done any setup for. So this is really, really useful if you need to set up something before each function. Let's say you have some default variables maybe that you need to set up. Well, in that case, this is a very useful method. Another one, just like setup, usually you add at the bottom of the file. And in here, this is called a tear down. And as the name suggests, we run it at the end of each method that we call. So in here, let's say cleaning up. And usually you do this to clean up some variables, maybe reset some variables. If I run this, you see that I have now about to test a function, and then we're cleaning up for each one of these methods. So these two are very, very useful when setting up and tearing down tests. Now, tear down you won't use as often. Usually you'd use it if you're testing something more complicated like a database, but we won't worry about that too much now. All right, there you have it for tests. As you can see, at the end of the day, tests are simply logical programs that we write, right? It's just a class, and then we set up all these methods to try and test our code as much as possible. In our case, we just had one simple function. But by using tests, we're able to notice small things that can go wrong with the function and thus improve our code. So that next time somebody comes, another developer comes and tries to modify this function, or maybe tries to call this function with something that is not right, well, our tests are going to fail and it's going to let the developer know, hey, you're doing something wrong. Somebody who wrote this function before you, somebody that wrote these tests before you, told you to use this function in a specific way. Very, very useful. In the next video, we're going to do a fun little exercise to make sure we understand testing. I'll see you in the next one. Bye-bye. Welcome back. Let's do a fun little exercise by revisiting a piece of code that we've written before. Remember the random number guessing game, where we had to guess a number between 1 and 10? If I run this file, you see that it asked me to guess. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. And I finally get the number. You are a genius. The number was 9. So how can we test this code? Now, one thing you'll notice here is that we don't really have a function. And remember when I told you about functional programming and how it's good to break up our code into small bits of functions that do one thing and one thing really well, especially pure functions? Well, one of the big benefits with that mentality is that you create code that is really, really easy to test. Instead of having really complicated logic in our tests, we can simply give our functions an input and expect an output. And this is why we have unit test. And the idea of a unit test is that we're testing each piece of unit. These unit tests are small little pieces testing these simple functions. So my challenge to you is to use this code and try to break this up into simple functions. Now, in our case, I want us to just test this part of the code, which is the guessing part, where we receive an input, which will be the guess, and then test it against some random answer that we have, and we should expect some sort of output. So either we enter a number, has to be 1 to 10, and if we get it right, we have to get the string. But the key here is that we probably want to move this into a function that we can test. We can ignore the outside world and break this up into its own little function. So pause the video here, give it a go. You're going to have to get through some stumbling blocks, but it's going to really test your understanding of tests. Haha, funny, that was a pun. So pause the video, give it a go. Otherwise, I'm going to get going with the answer. The first thing I want to do is to set up my test. Again, I'm going to import unit test. And I'm going to create the class test main. Or let's call it test script this time, or test game. I'm going to say unit test case. This is going to be our test case. And in here, I'll create, let's say, just a simple test. Let's say test game or test input. Receive the self. And for now, I'm just going to pass this because we're not really doing anything. Finally, I'll say if name equals to main, then run the unit test dot main. So this is just our simple setup. So if we run this now, let's say Python 3 test.py, you see that we ran one test. All right, so this is our setup. Next, what I want to do is actually take this out so I can use it in my test file by extracting it into a function. So I'm just going to say at the top over here, I'm going to define our guess game, or let's call it run guess. That's going to receive a input, or let's say a guess, and then it's going to run this code. So let's do that. I'm going to take this piece of code like this and simply paste it in here. Now, the wrong guess is also going to need the answer variable, so I'm going to give it a second parameter, answer, like this, so that now I can just simply, inside of here, run this function with the guess and answer, just like that. So let's save it here and run this test, or let's just run the actual file to make sure that it's still working. Oh, and we get a bit of an indentation error, so we have to make sure that our indentation is correct, because remember, in Python, that means something. All right, now we have an issue. We have a break outside of loop, because, well, we're using the break keyword, and, well, we're outside of a loop right now. So one thing we can do is we can say return here. So let's run that again and keep guessing a name or a number, and there you go. This is still working. I'm able to use return here because this, well, is going to run and return, but now we're still inside of the game. So maybe we can just return true and say if run guess is true, we're going to break out of this. Again, let's start our game. I'm going to just clear this and run the game again. 1, 2, 3, 4. And there you go. I've entered a number. I'm a genius. We've just finished the game. Let's make this a little bit smaller just so you can see. So we have our run guess. I've modified the code a bit, but the key thing is that I've extracted out a unit of functionality so that I can test something like run guess. So it looks like I've modified our code, but the code is still working. So now let's start testing our run guess function. Let's go here and start importing our script. And in here, do a few things. First, I want the answer to, let's say, equal 5. And the guess is going to equal 5. So we want to make sure that if the guess and the answer match, that, well, the run guess goes through the if statement and prints out you are a genius. Or in our case, returns true. So let's say self.assert equal that script, or actually, first time around, let's actually run it. So let's have result equals to script dot, what was it? Run guess, and give it the answer and guess. And we expect the result to return true. So we can just say assert true that the result is true. If I now run this, we actually start up the game. So how can we fix this? Well, we can close this and actually add the if name main in here. So down here, we'll say, hey, only run this if this is the main file being run, just like that. If I go back to test here and run this again, all right, now it's working, but I get an assertion error. Test game object has no attribute assert true because, well, I misspelled that. Let's try that again. All right, it looks like one test ran and everything is good. We also see that it printed out you are a genius. Very, very nice. By the way, I'm showing you this way of testing because this is how a real life scenario looks. you keep breaking things, you keep making mistakes, and then you try and fix them and correct your code. And you can see our code is already looking better and better just by running these tests. Okay, what else can we do? Let's say here that we're going to copy this. And just so things are shorter, I'm just going to directly enter the parameters in here. Just like that. Let's say test input, let's say incorrect. Or wrong guess. So let's say the answer is 5 and I guess 0. So we want to assert that this is going to equal false. So if I run this, 2 tests are passing. That's awesome. What else can we test here? All right, well, we want to test that if the guess is not between 0 and 10, or between 1 and 10, in that case, we want to have a print of, hey, Bozo, I said 1 to 10. So once again, I can test that if my guess, wrong number, let's say the answer is 5, but I give 11, we want to assert, well, right now we're printing and not doing anything. So maybe we should return false, just to have some consistency here. Again, if I do that and I run, there you go. 3 tests are passing. That's great. And there's many, many more tests that we can write. Maybe let's do one more test, which is to test what if the input is a string. If I run this, and make sure that wrong type here, make sure the names are different, and I have 4 tests running because this isn't going to pass and it's going to return false. Now, there's many more things that we can do here, but you can see the power of tests right now. If you have different tests than me, that's okay. Everybody's test cases are different. The whole point of testing is to just simply look at our code and see how we can improve it, how we can break our code, how we can simplify our code by breaking it into smaller units that can be tested, and fix some errors that perhaps we wouldn't have thought about. Now, there's many more things that we can do, but you noticed here how the idea was to work on small piece at a time, test it, and then maybe further on, we can look at this part of the code, or maybe the try and accept part of the code. And here's the thing. When you're working for a company, I argue that there are an infinite number of tests that you can do. You can have hundreds of lines here to test your code to bits. But just because you're testing as many times as possible doesn't really make your tests good. Like I said, there's an infinite number of tests that you can write. The idea is to write good quality tests that cover most of your cases, but eventually you'll have diminishing returns, where you have to have a trade-off between writing code and writing tests. And sometimes, depending on what the job requires, you might have to focus more on tests and focus less on code. Or sometimes maybe you need to move fast and you don't have time to write tests. And again, depending on the business needs, that might be the case too. But with this section, I hope you understand some of the principles following testing in software development. That is, bugs are always going to arise in our code. And we can use linting to help us with this, but one of the best ways to make sure that our code is working properly is tests. And the more tests that we have usually means the more stable our code. I'll see you in the next one.